Today in class, we talked about continental drift and seafloor spreading. And we're going to do a frame today that's going to focus on how the crust moves. The first topic we're going to talk about is continental drift. And understand that this is a hypothesis that was proposed by Alfred Wegener in the 1920s. According to the hypothesis, the continents were once a giant landmass that broke apart. Wegener called this landmass Pangea. He looked at 4 lines of evidence that help support this hypothesis. The first 2 lines are, the continents look like they could fit together like pieces of the puzzle. If you look at Africa and South America, they actually look like they fit together. Wegener also looked at climatic deposits, and he noticed that there were swamp deposits in continents, opposite sides of the ocean, in different climatic areas. He also looked at same fossils on different continents, so he found similar dinosaur fossils and plant fossils on opposite sides of the ocean. He also found same rock types on different continents that are on different sides of the ocean. There was a fault to his theory, though, or his hypothesis. He could not explain how the land masses moved. So this was, it was hard for people to believe his theory because he could not explain that. Now, later, during World War II, seafloor spreading was discovered. And this idea comes from the new seafloor forms when magma rises and hardens at the mid-ocean ridges. Well, we know that the plates ride on top of the asthenosphere. Well, when they spread apart at the ridge, pressure gets released, and some of that asthenosphere can melt, and it turns into a magma. So that's where the magma comes. And if you look at the rocks starting from the ridge and moving away, we notice that the rocks are younger near the ridge and they're older as you get farther and farther away. Geologists also looked at magnetic reversals. It could be 100,000 years, it could be 1,000,000 years. We have these rock records where we can see that the poles have flipped. And these reversals actually get recorded in the rock because the basalt in the ocean floor has iron in it, and the iron will align itself with the magnetic poles. And seafloor spreading helps support continental drift, which help prove Wegener's hypothesis. So why do we need to understand this? Well, they both are going to support crustal movement, or actually the idea that the plates are moving. In our extensions, all the labs we did a continental drift station, we did the seafloor spreading station, so all of these are extensions and help support this idea of continental drift and seafloor spreading.